Hello everyone. We are starting with Algebra, the 12th lecture of Algebra. So this is Algebra and this is lecture 12. So finally, we have reached a new stage, and this stage is about sketches and it's about graphs. So these are the things that we will be focusing on. Now, first of all, what is the difference between a sketch versus a graph? First of all, sketch could be drawn anywhere. It could be drawn on a piece of paper. It could be drawn on a glass surface. It could be drawn on a whiteboard. So anywhere we can draw a sketch. Whereas graph has to be drawn on graph paper. A graph paper or a grid, something like that. If that's given, that is a graph. What else is the difference? The second difference, this is the first difference. Now the second difference is a basic idea is needed. It could be about slope, it could be about gradient, it could be about turning point, it could be about the y-intercept, it could be about the x-intercept, it could be about the shape of the graph. So that's how the sketch will be drawn. What about the graph, the exact graph? So the exact graph, you need a table of values. And you need to fill in those table of values. This is x, this is y. You need to fill in this. And then you need to plot these points. These are called points, or these are called coordinates. These are also called vertices. So this needs to be plotted. So in short, we can say sketch is a rough idea, realistic but rough. Whereas graph is exact. Within the limits of human error, a point could be plotted slightly wrongly. That is possible. But a graph is exact, whereas a sketch is rough but realistic. So that is the basic idea. So now what we can get started with is this thing. That is that if we talk about straight line. So let's start with linear graphs. And we'll be dealing with every single kind of graph. That is within the syllabus of O-Level Maths 4024, or the same goes for IGCSE. Let me just check one thing. Why is the brightness very bright? Okay. So now, I don't know, this something is there. Hold for a second. Okay. So now we are talking about linear graphs. That means straight line equation. Y is equals to mx plus c. Y and x and y, they are variables. Whereas m and c, they are constants. This m, that is the slope of the graph. And C, it's called the y-intercept. So now when we draw a graph, what happens is that we need to look at the slope, we need to look at the y-intercept, and we plot it. So now first of all, let me draw some lines. So let me draw a line like this and a line like this. Now this line has a positive slope, also known as gradient. We are not going into coordinate geometry. We are not studying coordinate geometry right now. We are just studying sketching. So we'll just need to get the basic idea. So that is a positive slope. Why? Because if x increases, y increases. Something like direct proportionality. X increases, y increases. X decreases, y decreases. This is called direct proportionality. That has a positive slope. The blue line is climbing down the stairs. If x increases, y decreases. If x decreases, y increases. Just have a look. X is increasing to the right, but the height is decreasing. So this is like climbing up. This is like going down. So that's how you have a feel whether it has a positive slope or a negative slope. All good? There could be a possibility in which the slope is like this. Let me draw it. A slope could be like this. A slope could be like this. So this one is a zero slope. Why? Because there is no change in height and it's a horizontal line. Whereas this line is an undefined slope and there is no change in base. As opposed to height, I'm using the terminology base. And this is a vertical line. So now over here, let me draw different kinds of graph. First of all, if I have some kind of grid ready, I think that is a grid. Okay, that looks good. So I just want to change the color. Let's make it black. Okay. And let me copy this. I'm just copying this thing. So I have drawn 4 grids like this. And let me draw a line. First of all, a red line going like this. Let me make it thinner. Like this. A red line going like this. A blue line going like this. Another blue line going like this. Now just look at it closely and think what are the similarities and what are the differences. So you're seeing 4 graphs and you have this knowledge. And by the way, what is y-intercept? Where the graph cuts the y-axis. So first of all, the y-intercept, this is x and y like this. And this is x and y. This is x and y. This is the y-intercept over here. This is the y-intercept over here. This is the y-intercept. Let me just erase this. This is the y-intercept over here. And this is the y-intercept over here. So now this y-intercept is positive. This y-intercept is negative. It's below the x-axis, above the x-axis. That's a basic idea you already have. This is positive. This is negative. Over here, the red slope is the positive slope. So this is positive c. This is negative c. This gradient is positive. This gradient is positive. Do you agree? It's going up. This one is also going up. The only difference is y-intercept is above x-axis. So above x-axis is positive. Below x-axis is negative. Over here, what should I write? I'll write y-intercept is positive. I'll write y-intercept is negative. I'll write gradient as negative. I'll write gradient as negative. So let me just change this thing over here so that it's all synchronized. So positive, 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 but negative. And that's how it is. All good, all clear? Take out your WhatsApp. Just acknowledge it over there that this is all good, all clear. I'm just waiting for your WhatsApp. Okay, over here. And then I'll involve some equations. And let me just copy this thing over here. Okay. Let me paste it over here. Now over here, if I write some equation, a possible equations. So these are possible equations that could be corresponding to these diagrams. This could be like y is equals to 2x plus 3, something like this. So let me just adjust it. It has a positive slope. It has a positive y-intercept. So positive slope, positive y-intercept, mx plus c, of the format y is equals to mx plus c. This one could be y is equals to 3x minus 4. Positive slope, but negative y-intercept. This one, y is equals to minus half x plus 2. So this is negative slope minus half. It could be in fraction also. And this positive 2 is the y-intercept. And let's say I can write x plus y plus 3 equals to 0. First make y the subject. Y is equals to negative x negative 3. So now the gradient is negative 1, the y-intercept is negative 3. All good? All clear? So that is the basic idea, but wait a minute. There is something more to it. What is more? So let me just change the color. Let me make it black and let me add an element. So the new collection, the grid thing. Okay. So now over here, let me just paste some more. No, not this. Okay, so now let me look at the color. Green color I have used for zero slope. That's right over here. Purple color for positive slope. So now over here, a green color for zero slope, it goes like this. A green color could be going like this. A purple color is going like this. Another purple color is going like this. Now, first of all, this is x and this is y. And let's say this y-intercept is 3. This is y, this is x. No, not this. The other one, this is x. And this y-intercept is negative 2. This is y, this is x. This x-intercept is 1. This is y, this is x. And this x-intercept is negative 2. So now, y-intercept, that is 3. And this is y-intercept, that is negative 2. This is x-intercept, that is positive 1. This x-intercept, that is negative 2. So I can just remove the positive sign. I can simply write 1. Now all along this line, the y-coordinate is not changing. It's 3. All along this line, the x-coordinate is not changing. It's negative 2. So the equation is y is equals to 3. The equation is y is equals to negative 2. Similarly over here, all along this line, the x-intercept is 1. All along this line, the x-intercept is negative 2. It's not changing. So therefore, I'll write x is equals to 1, x equals to negative 2. So that is the basic idea that is needed. So far, so good with this thing. Let's move on. And let's talk about let's say quadratic. So now let me draw this. Let me write over here quadratic sketch. Now when we talk about quadratic sketch, the basic quadratic is y is proportional to x square. Let me write it like this. Y is proportional to x square. So I'm bringing in the proportionality over here. Or y is equals to kx square. And let me just plug in some points. Let's say when x is 2, y is 4, find y in terms of x. So this is y in terms of x. Let me just shift this thing, hold for a second. Okay. So y is proportional to x square, and this is the equation. Let me just correct myself. All good, all clear. So now what is the working? The working is plug in the values. Y is equals to kx square, y is 4, x is 2, that is k times 2 square. Therefore 4 is equals to k times 4, therefore k comes out to be 1. Therefore the equation is y is equals to 1x square. Now let's draw the sketch of this. Y is equals to 1k square. So now let's move to the next page, and it's about the same quadratic sketch. Let me just copy this from here. Let me paste it over here. Let me draw a table of values. So, okay. Now over here, we have, I think it's kind of a bright color. So let me choose the color. Okay. Now let me write over here x. Let me write over here y. And let me choose the values. -3, -2, -1, 0. Let me write 0 over here, and then a 1, and then a 2, and then a 3. Now this is what we have. And the equation is y is equals to x square. It's a function that squares the thing. So whatever the value of x is, it squares it. So -3 whole square is +9. -2 whole square is +4. -1 whole square is +1. 0 square is 0. 1 square is 1. 2 square is 4. 3 square is 9. These are the values that you obtain. Now what do you observe? You observe that when x is 0, y is 0. When x is positive, y is positive. The green values. The red values, when x is negative, y values, the red values are again positive. That means this graph can become 0, this graph can become positive, but it can never be negative. So let me write the statement over here. The y values over here, I'm focusing on the y values. These are positive. These y values are positive. This y value is 0. In other words, y values can never be negative because it is squaring. All good? Positive remains as positive. 0 remains as 0. Negative becomes positive. So this is all because of this. That is the concept of y is equals to x square. So that is y equals to x square, positive, 0, positive. That's right over here. Now let me draw the idea. And let me just pull that thing out, which is this thing. All good. So over here, the first thing, the blue value, when x is 0, y is 0. That is this value right over here. And then we have 1, 2, 3, and the green values. So let me make it very small. So this is like 1, this is like 2, this is like 3. And this is like 1, 2, 3, 4, 5, 6, 7, 8, and something like that. So let me just focus on these two values and these two values. So that will give us the idea. When I plug in 1, I get 1. So that is, I think, the green color. Yeah. So 1, 1, that is 1 point, and 2, 4, that is the other point. And then we have which color? The red color. And over here, let me plug in, this is -1, this is -2, this is -3. So this is -1, -2, -3. So -1 is giving me 1, and -2 is giving me 4, something like this. And now when I join these points like this, so that's how the graph comes out to be. This is not an exact scale, keep that in mind. So this is 1 point, this is second point, this is third point, this is fourth point, this is fifth point. And if I keep on going, the graph will go up like this, the graph will go up like this. So this is y, this is x. Now let me draw it again, and this time without the points. So without the points, if I draw it, and I'll make the marker a bit thicker, and I think that is good enough. Let me just draw the graph like this, and let me pull it over here. So that is how the graph of y is equals to x square will look like. This is y, this is x, this is the origin. When x is positive, y is positive, but it's increasing very fast. When x is negative, y is still positive, but it's increasing very fast. So now I'll just pause here for a second so that you can understand it thoroughly, and I need some acknowledgement on the WhatsApp. So let me just pause for a second. So now we are starting with more quadratic, but this time in this quadratic, what is happening is that we have the graph of y is equals to -x square. So we have drawn it for y is equals to x square. Let me just take this thing over here, and let me do some adjustment to it. So I've copied it, and let me paste it over here, and let me just erase this thing. Hold for a second, and this whole thing over here, I'll just shift it up. So now my focus is y is equals to negative of x square. So this is y equals to negative x square. Now what will change? Think about it. All these y values which were once positive, they will become negative. So let me just use the eraser over here. The positive 9 will become negative 9. Positive 4 will become negative 4. Positive 1 becomes negative 1. 0 remains as 0. And what about positive 1? That becomes negative. This is negative. This is negative. Why? Because of this negative sign. As simple as this. Now I'll write this y value is negative, this y value is negative. Y values can never be positive. They can be negative, they can be 0, they can never be positive. And let me write it more comfortably. So this is y is equals to negative of x square. Now when I have to draw this graph, let me just choose this thing. It's upside down. So now let me choose a pink color from here. Let me choose this. Let me choose this like this. Now the graph is like this. Just the basic shape. And this goes like this. So over here, what do we have? This is the blue color when x is 0, y is 0. And over here, what else do we have? When x is positive, y is negative. So this is positive and then negative like this. And over here, when x is negative, y is negative, something like this. So now that is the basic idea. This is y, this is x. That's the graph of y is equals to negative x squared. So positive x squared is like this, negative x squared is like this. So in short, I can say when the graph is like this versus the graph is like this, so this is y is equals to positive x squared and this is y is equals to negative x squared. This is like a happy face graph. And the other one, this is like a sad face graph. Okay, so that's how the graph looks like, the happy face and the sad face. Let's move on. Let's talk about the idea of a cubic graph. A quadratic curve, a cubic graph, or a cubic curve. Again, let me draw a table. And again, let me change the color to sharp. And this is the color that goes like this. Okay. We have the x value. We have the y value. Let me plug in -2, -1, 0, 1 and 2. The equation is y is equals to x cubed. Let me first do the needful. Let me put the grid over here. And similarly, if I just take this thing and shift it on the next page, and the grid that goes somewhere over here like this. Now cubic curve y is equals to x cubed. What is the property? If x is positive, it will remain as positive. If x is 0, it will be 0. If x is negative, cube of a negative number is negative. That is the basic idea. So now over here, -2 after cubing is -8, -1 after cubing is -1, 0 remains as 0, 1 remains as 1, and 2 remains as 8. That is the basic idea. So now these two are negative. This is 0. These two are positive. Let's plot it. So I need the y-axis. I need the x-axis. This point is the origin. That's right over here. When x is 1, y is 1 somewhere over here. But when x is 2, y is 8. That is way up here. That is a very sharp rise. Similarly, when x is -1, y is -1. When x is -2, y is somewhere over here like this. Now, if I join these points, look at how the graph looks like. So this goes like this, and this goes like this. So let me highlight those points. This is one point, this is the other point. That is the blue point, that is the green point, that is the green point. That's how the graph would look like. When x is positive, y is positive. When x is negative, y is negative. So now that is the graph of y is equals to x cubed. And over here, y is equals to -x cubed. Let me just copy this thing. Let me paste it over here. And let me just do one thing again. Y is equals to -x cubed. And now because of this negative, what will happen? -2 cube is -8, but because of this negative, it will become +8, +1. And because of this negative, this 1 will giving me -1 and 2 will give me -8. 0 will remain as 0. These are the values that we have. Now the shape of the graph, I'll draw the shape first because that is what we are focusing on. I'll draw the shape first, and this type, the shape is like this and like this. This is like more prominent. I can do the same that thing for the other one also. So this is -2, -1, -1 and +1. So that is 1 point. -2 and +8, that is the other. 0 remains as 0. -1 is giving me +1 and +1 is giving me -1, and somewhere over here is like this. So now this is x, this is y, this is y is equals to -x cubed. Now it's time for a little bit of thinking. What is that thinking? That thinking is, first the graph of y is equals to x square was like this. The graph of -x square is like this. That's this one. Because of this negative, it is reflected in x-axis. Just have a look. This is like this. This is like this. So now the first thing that you realize, y is equals to x square and y is equals to -x square are reflection of each other in x-axis. So that is the first prominent thing that you notice. Similarly, this is y is equals to x cubed. This is y is equals to -x cubed. Let me draw both of them side by side. Over here, no, not this, and over here, like this. So now, let me just draw this thing. Like this, like this. This is y is equals to x cubed. Y is equals to -x cubed. Now, are they reflection of each other? Yes, this thing goes down and it goes like this. So this one is like this one. That's this thing. Let me just change the color so it becomes more obvious. So hold for a second. Let me choose this color, and that's this thing. Color, and that's this thing. Okay, oh, so far so good. This color is like this. Okay. Okay, so now again, y is equals to x cubed, y is equals to -x cubed. They are reflection of each other in x-axis. So this is x, this is y, this is x, this is y. That's how the graph is drawn. So we have gone over the linear graphs, the quadratic graphs, the cubic graphs. Now, what else can we go over? Let's talk about the power function. So if I talk about the power function, so let me just write it over here. The power graphs, also known as exponential graphs. The word index, power, exponent means the same thing. The plural of index is the chapter that you study, which is called indices. And the chapter of exponent is also known as exponents. And the word exponential is out of this. So now, what kind of graph are we talking about? So let me just draw this thing, pick this thing up. Let me also paste it over here. So now for power graphs, if I draw a table of values, which I need to in the beginning, not later, initially I need to. Okay, and let me write down the values, the x, the y, -3, -2, -1, 0, 1, 2, and 3. I think it's a little bit misplaced, so let me just write it correctly. This is -3, this is -2, this is -1, this is 0, this is 1, this is 2, and this is 3. Again, let me select this thing and paste it on the other page. And what else do I need? I need the grid. So that grid is right over here. And I need the grid. That grid is right over here. No, not this. Okay. Now, y is equals to 2 raised to power of x. There is a base, it has a power. This is of the format y is equals to a power x, where a is positive. And over here we'll be talking about y is equals to a raised to power of -x, a is still positive, the base is positive. 2 raised to power of -3, that is 1/8, it's not negative. 2 raised to power of -2 is 1/4, -1 is 1/2, 2 raised to power of 0 is 1, 2 raised to power of 1 is 2, and then 4, and then 8. What do you notice? The first thing to notice is that it's never negative. That is the first and foremost thing. The second thing to notice is, my bad, let me just correct myself. That is this thing over here. And let me just change the color. So this thing over here, 2 raised to power of 0 is 1. Okay, so that was one small mistake. And let me correct myself and this thing. Okay, that is the thing that we have. So the y value at 0 is 1. So that is 1 over here. And then if I have these values, that is 1, and then there is 2, then there is 3. So the y value is 2, 4, and 8. So the value would be over here, and then over here, and then high over here like this. And what about the values in red? For -1, let me write -1 and -2 and -3. So that would get very, very small. It's not 0, but it's very, very small. So it's like this, it's like this, it's like this. That's how the graph would look like. And now if I want to draw it, let me choose purple color. And not this thing, the purple color, and like this. So the graph goes like this. That's a power graph. So therefore, this value is there, this value is there, this is there. Then the blue value, just focus on the colors. That is this value, and this value, and then this value. So not over here, somewhere over here. Let me just erase part of the graph. So let me just erase like this. And naturally, it will keep on going like this. It will keep on going like this. It will not touch the x-axis. The curve will not touch x-axis. How do I know that? I know that because if a base is positive, a raised to any power can never be 0. It can never be negative. So it will get very close to it, but it will never be 0. For example, 2 raised to power of 10 is 1024. 2 raised to power of 11 is 2048. So if I choose y is equals to 2 raised to power of x, if x is negative 10, y is 2 raised to power of negative 10, which is 1 over 1024. It will become very small, but it will not be negative. If x is negative 11, y is 2 raised to power of negative 11, or 1 over 2 power 11, or 1 over 2048. Let me also write it like this. So this is 1 over 2 raised to power of 10, or 1 over 1024. In other words, it can never be negative. It can never be 0. It can never be negative. It will always be positive. Always be positive. And that's how the graph looks like, the power graph. Now the next important thing is the y-intercept. That is always 1. The value of c is 1. Let's not write c. Y-intercept is 1. But now if I have the values changed, if I have negative 3, so now 2 raised to power of negative 3, that is 2 raised to power of 3, which is 8. So now this is 8, and similarly this is 4, and this is 2. This is still 1, and the green one is half, and 1 over 4, and 1 over 8. Look at the values. 8 becomes 1 over 8, 4 becomes 1/4, 2 becomes half. Over here, it was the other way around. So now, instead of plotting, let me just go ahead and draw the graph. The graph would be something like this. So now these y values would be like that. So therefore negative 3 would be like this, and negative 2 would be like this, and this one would be like this. This value would be right over here, and then the green values, that is like this and like this and like this. So this is y, this is x. Again, will not curve, will not touch x-axis. That is the thing. And what else is there? Y-intercept is 1. And if I compare these two graphs, now let's look at the two graphs. So first of all, let me draw this graph like this. And let me draw this graph like this. So if I look at these two graphs, what do I notice? I notice that they are reflection. Let me make it thinner. Reflection of each other in y-axis. So let me just draw the grid. So first of all, if I draw the grid, where is it? So let me just put it right here, somewhere like this. And if I choose the grid, let me put it right over here, something like this. So reflection of each other in the y-axis, this is the value 1, this is the value 1. This is y is equals to a power x. This is y is equals to a power negative x. A could be 2, a could be 3. The graph would still remain the same. So let's stop over here. This is lecture number 12 and signing off for today. Inshallah, see you in the next class.